Have you ever gazed up at the night sky and wondered if we're alone in the universe? It's a question that has captivated human minds for millennia, sparking countless debates, theories, and science fiction tales. But beyond the realm of speculation, there is real, rigorous science happening right now, aimed at answering this very question. From the icy moons of our own solar system to the deep reaches of interstellar space, scientists are hunting for signs of life beyond Earth. This pursuit, this cosmic treasure hunt, is not only about satisfying our curiosity. It's about understanding our place in the cosmos, our origins, and perhaps our future. The search for extraterrestrial life drives much of our exploration of the universe. We deploy sophisticated telescopes, develop complex algorithms, and venture into the unknown, all in the hope of catching a glimpse of life's cosmic signature. But where do we even begin to look in this vast universe? The key to this cosmic puzzle might lie in a concept called the habitable zone. Imagine a cosmic Goldilocks scenario, not too hot, not too cold, but just right for life to exist. That's the habitable zone. Picture it as a ring-shaped area, a celestial sweet spot around a star where conditions could allow liquid water, a vital ingredient for life as we know it, to exist on the surface of a planet. But it's not as simple as just finding the right temperature. The habitable zone is influenced by a symphony of cosmic factors, each playing a part in creating just the right conditions. The star's luminosity, or brightness, is one such factor. The brighter and hotter the star, the further out its habitable zone. Conversely, smaller, cooler stars have habitable zones much closer to them. The star's size and temperature also play a role. Larger, hotter stars have wider habitable zones, while smaller, cooler stars have narrower ones. But even within the habitable zone, not all planets are equal. The planet's atmospheric composition and distance from its star also determine whether it can hold on to that precious liquid water. For instance, a planet with a thick atmosphere might be able to retain enough heat to have liquid water, even if it's a bit further from its star. On the other hand, a planet that's closer but has a thin atmosphere might not be able to hold on to its water, allowing it to escape into space. So you see, the habitable zone is not just a matter of distance, but a delicate balance of multiple factors. It's a celestial jigsaw puzzle, and every piece must fall into place to create a world where life might thrive. This Goldilocks zone is where astronomers focus their search for potential life-bearing worlds. They're scanning the cosmos, looking for planets that are not too hot, not too cold, but just right. And who knows, maybe one day they'll find a planet that's not just right for life, but teeming with it. Our universe is teeming with planets, but finding those in the habitable zone is like finding a needle in a cosmic haystack. To detect these elusive exoplanets, astronomers employ a range of methods and cutting-edge technologies. One popular technique is the transit method, where scientists watch for a dip in a star's brightness when a planet passes or transits in front of it. Space telescopes like the Kepler and TESS have been instrumental in using this technique to identify thousands of exoplanet candidates. Another technique is the radial velocity method, which observes the subtle wobble of a star caused by the gravitational tug of an orbiting planet. Ground-based observatories, like the W.M. Keck Observatory in Hawaii, specialize in this method, but finding an exoplanet is just the beginning. Determining if it lies within the habitable zone requires further analysis of its star's properties, its orbit, and its potential atmosphere. This is where space-based observatories like the Hubble and the upcoming James Webb Space Telescope come in. These mighty eyes in the sky scrutinize the light from distant stars to reveal the chemical makeup of exoplanet atmospheres, offering clues about their habitability. In recent years, these techniques have led to some fascinating discoveries. Take Proxima Centauri b, for instance. Orbiting the nearest star to our solar system, this exoplanet resides in its star's habitable zone, raising exciting possibilities about its potential to support life. Another intriguing find is TRAPPIST-1, a system of 7 Earth-sized planets, 3 of which are in the habitable zone. These are but a few examples of the countless worlds that could exist within the habitable zones of their stars, each one holding the potential for life. The search for habitable exoplanets is an ongoing endeavor fueled by our insatiable curiosity about the cosmos and our place within it. Each discovery is a step closer to answering the question, are we alone? Defining habitability is not as straightforward as it might seem. As we delve deeper into the complexities of the cosmos, we realize that the concept of a habitable zone is riddled with challenges and uncertainties. The first of these challenges lies in the myriad factors that can influence the conditions on a planet, making it conducive for life. Take, for instance, the atmospheric composition of a planet. A planet might sit comfortably in the Goldilocks zone of its star, yet if its atmosphere lacks the right mix of gases, it may not be able to sustain liquid water on its surface. The presence of greenhouse gases, for instance, can trap heat from a star and warm up a planet, potentially extending the boundaries of the habitable zone. Then, there's the role of geological activity. Planets with active geology can have their atmospheres altered over time, changing the planet's potential for habitability. Volcanic eruptions, for instance, can release gases into the atmosphere that can either warm up a planet or cool it down, depending on the composition of the gases. The position of a planet within its solar system also matters. Planets in a binary star system where two stars orbit each other could have their habitable zones complicated by the gravitational forces of two stars. Furthermore, our understanding of life itself presents a challenge. We base our definition of habitability on life as we know it, life that relies on liquid water. But what if there are forms of life out there that thrive under completely different conditions? What if there are organisms that don't require water or oxygen, or perhaps even organisms that can survive in the harsh vacuum of space? These are the uncertainties that make the search for extraterrestrial life both exciting and daunting. They remind us that our understanding of the universe is constantly evolving, and what we consider a certainty today might be proven wrong tomorrow. As we continue to explore the stars, we must be prepared to challenge our assumptions and expand our definitions. The quest to understand where life might thrive in the cosmos continues. So, what would it mean if we found a habitable exoplanet? Well, it would be nothing short of a cosmic revelation. Uncovering a world that could potentially harbor life would transform our understanding of life's prevalence and diversity in the universe. It would be a testament to the resilience and adaptability of life, reinforcing the idea that if the conditions are just right, life can take root and flourish. Imagine for a moment an exoplanet with conditions similar to Earth's. It would likely host a dizzying array of life forms, from the microscopic to the massive. Now consider this. If life can exist in multiple forms on two separate planets in the same universe, then the possibilities for life beyond our solar system are virtually limitless. Every habitable exoplanet discovered would bring us one step closer to answering the age-old question, are we alone in the universe? But more than that, it would challenge our perception of what it means to be alive. Because if life can exist under conditions vastly different from those on Earth, then our definition of life needs to be broadened. Such discoveries could also reshape our understanding of our place in the cosmos. We've long viewed ourselves as the center of the universe, but the discovery of habitable exoplanets would be a humbling reminder that we are but a tiny part of an unimaginably vast cosmic tapestry. And let's not forget about the potential for future exploration. Finding habitable exoplanets could pave the way for humanity's next great adventure. Who knows? Maybe one day, our descendants will set foot on these distant worlds, pushing the boundaries of human exploration even further. The search for extraterrestrial life is more than a scientific endeavor. It's a journey of understanding who we are in the vast expanse of the universe.